You got to remember, the first thing you want to do is get the absolute value alone on one side. So that means I have to subtract 2 on this problem. So I have the absolute value of x minus 2, which is less than 8. Okay, now I've been kind of teaching you to box that there, because that's where we're going to test in a little bit. All right, so now once that's boxed, you got to kind of pretend it says equal. And when that says equal, we want to split. Notice I have equal signs now. X minus 2 equals 8, or x minus 2 equals negative 8. I don't have any equality symbols here. A lot of you continue to do that. So make sure you make them equals. So I'm going to add 2 to both sides, and I'm going to get an x value of 10. And over here, when I add 2 to both sides, that gives me an x value of actually negative 6. Well, then the next step is to literally just put those in here. So negative 6 and 10, get them on my number line here. Well, now the next thing I have to do is test values. Now we've been talking about less than, meaning a smaller distance. It's going to be in the interior here, but also just watch how testing points works. If I put an 11, just listen to my voice here, an 11 minus 2, that's going to be a 9. So if I showed my work to that, it'd be like 11 minus 2, that'd be the absolute value. That's going to be the absolute value of 9, which is 9. But we're checking to see if this is smaller than 8 the whole time. Is that smaller than 8? Well, 9 is not smaller than 8. 9 is bigger. So this is a false region. If I pick a point in here, that would be 0. Look at 0 minus 2, that's negative 2. But the absolute value of negative 2 is 2. 2 is less than 8, so I get a true statement there. And then over here, if I pick a negative number, like let's just, I'll test one with you, negative 7. If I do negative 7 minus 2 to check to see if that's less than 8, be very careful. Negative 9 is less than 8, but you have to keep the absolute value symbols going. So this is actually saying, is 9 less than 8? And it's not, this is false. So what do we notice about this? Well, what we notice is this is the true region right there. So I want to shade everything in the true region. Well, it's not a bracket, it's a parenthesis problem because of where I'm pointing right now. So it'll be a parenthesis there, and then all the way to here, and then we would literally just manipulate interval notation from that. Okay, so I hope that helps. Here, just watch very carefully. As I divide, not add, as I divide by negative 2 here, I get just x plus 4 in the absolute value, but I divide it by a negative, so I'm going to have to flip that sign. Remember, flip that sign, so that's going to be a greater than or equal to, and it's a positive 11. So that negative became positive, and I'm good there. Okay, once again, we want to box that. We want to make sure that this is where I know to test. So now I pretend that says equal, and I would say x plus 4 is equal to 11, or x plus 4 is equal to negative 11. And then I solve each of these, subtract 4 to both sides, I'm going to get a 7. Subtract 4 to both sides, I'm going to get a negative 15. Okay, so here's negative 15 right here, and then over here we have ourselves a 7. So basically when we look in here, we got to be able to shade. Well, it's greater than, so it's going to be the outside regions, but listen to my words very carefully as I do this. I'm going to plug in an 8. What's 8 plus 4? 12. What's the absolute value of 12? 12. Greater than or equal to 11, that means that's a true statement. And if I did that one correctly, which I'm confident I did, for all of these absolute values, they will go every other as far as the region go. If you don't trust me on that, plug another value in. Pick something in here, plug it in, it'll be false. Pick something here, plug it in, it will be negative. But I do have brackets on this problem, so I do my brackets, and then I go this way, and then I do my bracket. That should be right on the 7. I kind of missed it right there. You should try to get right on that 7. But then interval notation, here we go. Practicing this a lot, from left to right. How far left do I go? Well, that's all the way to negative infinity. And I keep going all the way to, negative 15. I put a bracket because I include that. Union, start at 7 then. 7 to infinity. And there we are, okay? So now the next one, we got 2 more here. We got to divide by 3 right away. So I just divide by 3, and then I have x minus 1 is greater than 8. Box that. Here we go, a little faster. X minus 1 is equal to 8. Or x minus 1 is equal to negative 8. Add 1 to both sides, I'm going to get myself a 9. Add 1 to both sides, I'm going to get myself a negative 7. Negative 7 on the left. 9 on the right. Are we having fun yet? I hope so. And then what do I want to pick? Well, if I put a 10 in, I like picking here because it's easier to do. What's 10 minus 1? 9. Absolute value of 9 is 9. Is 9 greater than 8? Yes, it is. It's true. And we also talked about greater than being the outsides. I've said that like 3 times now in this video, so hopefully that's kind of ringing true. True, false, true on this one. It is not a bracket problem, so I put my parentheses right on my numbers there. And I have myself my answer of, again, negative infinity all the way to negative 7, union 9 to infinity. All right, last one here. I need to add 6 first because I want to get that negative 6 out of there. So now I have the absolute value of 3x, which is less than or equal to 18. That looks a little different on the inside, but don't change anything. Just 3x is now equal to 18, or 3x is equal to negative 18. So we're going to test back here, but these are giving me my 2 values. Divide by 3 to both sides and you'll get a 6. Divide by 3 to both sides and you'll get a negative 6. So now I just go here and I'm like, oh, negative 6. Over here I say 6. And again, I got to test values. Well, what's a good one? Let me try a different region here just so you're comfy. 0 is definitely right in here. Well, what's 3 times 0? 0. What's the absolute value of 0? 0. 0 is less than or equal to 18, so this is a true. So that means that these outsides have to be false. But just think about this. If I put in a 7, which is over here, 7 times 3 is 21. Absolute value 21 is 21. That's not smaller than 18, so it's false. So it doesn't really matter where you pick. As long as you pick it and you do it correctly, then you can fill in the other regions. Okay, this is a bracket problem, so it's right here all the way to there. And then interval notation from that is just great. It's right off of our graph. Okay, I hope this helped you.